everyone, today we're going to be working with the problem, Jimmy has 200 marbles. 119 of them are red and the rest of them are blue. How many blue marbles does Jimmy have? Our equation for this problem is 200 minus 119 equals our unknown problem, or the number of blue marbles in our equation. We'll start our equation using our base 10 blocks, where we have 200 base 10 blocks. One of these squares represents one group of 100. So our first step for this problem would be to look at our equation and see that we need to start in our ones place. Our equation is telling us that we need to take away 9 ones. However, there aren't any ones to take away. So we would go to our tens place and decompose one of the tens, but we don't have any tens. So our next step is to go to the hundreds place and decompose one group of 100 into 10 groups of 10. I've decomposed a group of 100 into 10 groups of 10, but I still don't have any ones. So once again, I'll have to decompose. This time, I'll select one group of 10 and decompose it into 10 individual ones. Now that I have individual ones, I can go back to my equation and see that I need to take away 9 ones. So now I'll cross off 9 ones to take away. I've crossed off my 9 ones, but before moving to the next step, I want to go to our US standard algorithm and show that what we just did with our base 10 blocks, we can also do with our US standard algorithm. If we look at the 0 and the 9 in the ones place, we notice that we need more ones in order to subtract. So we go to the tens place. However, just like in our base 10 blocks, there wasn't any tens to decompose. So we go to our hundreds place and we'll decompose one of our groups of 100 into 10 groups of 10. So I'll mark off the 2 and leave 1 to show that I still have one group of 100. And I decomposed the other group of 100 into 10 groups of 10. But once again, we're still looking for ones. So I need to decompose again. So I'll decompose one of our groups of 10. So I'll have 9 groups of 10 left. And then I'll have 10 individual ones. Now that I have ones, I can subtract, and 10 minus 9 equals 1. We have 1 left in our standard algorithm and 1 left with our base 10 blocks. So now we can go to the next step. Let's go back to our base 10 blocks. Our next step would be to go to the tens place, and it shows that we need to take away one group of 10. We have plenty of tens, so we need to just mark out one group of 10. Our next step is to go to the hundreds place, and we need to mark out one group of 100, and we see we still have one group of 100. So now, after doing this, we've taken away all we need to take away. So now we just need to count up what we have left. We have no hundreds. If you count, we have 8. Groups of 10, and we have 1. So we have 81 is our answer. Go back to our standard algorithm. We go to our tens place, and 9 minus 1 equals 8. And then if we go to our 100 place, 1 minus 1 equals 0. So even though these are represented differently, they both come out with the same answer, and we're doing the same things with each problem, just representing them in different ways. So our answer for our equation, 200 minus 119 equals 81.